Our brains are smarter than many computers, but at the same time they are so easy to fool. Don't believe me? Check it out for yourself. Glance, it seems that the blue lines are definitely slanted relative to each other. In fact, they are strictly parallel, and the deceptive effect is created by the combination of colors. You can check this by looking at the picture with a slight squint and slanting your eyes. All the circles in this photo are the same color, but it seems to us that they are painted in different tones. In fact, the only difference is the colored lines that surround them. They're the secret. You think you're looking at a GIF? Well, it's not. This is a simple static picture, and all the movement on it is created in your head. The light shading and the drops lined up in the right rows trigger the illusion of movement in your brain. By the way, about 5% of people are not susceptible to it. Write in the comments if you are among them. The image appears to be two pictures of the street from different angles. In reality, it is the same image copied twice. The brain is fooled by the curves, which look parallel in the photo, which in reality can only be the case if you look at the road at a high angle. The circles in this GIF change in size as you move back and forth. Think the orange circle in the center is shrinking and getting bigger? Turns out it doesn't. This illusion is created by changing the size of the gray circles. When looking at this GIF, there is no doubt that the blue and red segments are changing lengths as if in rippling waves. They aren't. They have the same length, and the catch lies in the moving shoulders of the arrows, which confuse our perception. Look carefully at the picture. Is the train going into the tunnel or, on the contrary, leaving it? You may be surprised, but there is no right answer. It all depends on how you look at it. With a little practice, you can even learn to control the train, making it move in the right direction. Another brain-breaking GIF, which dramatically changes the essence depending on the point of view. If you look at the colored circles in the center and move your gaze from one to another, the gray circles will rotate one way or the other. The illusion is based on the difference in the perception of motion when the object is in the center or on the border of peripheral vision. Look at the picture of the cake. Do you see the red strawberries? Are you sure it's red? But there is not a single scarlet or even pink pixel in the photo. This image was made using shades of blue, but we can still see that the berries are red. The artist used the same lighting change effect that divided the world into two camps because of the color of the dress. And this is not the most delicious picture of the master of illusion. And lastly, the coolest illusion of all. Van Gogh's famous painting is static, with not the slightest hint of movement. But look for 30 seconds at the spinning spirals above, and then shift your gaze to Starry Night. Pretty cool, right? The point of this illusion is the after effect of motion. When we stare at the spirals for a long time, the visual system begins to compensate for motion to reduce this predictable stimulus. But if we look at a static picture immediately, the brain will continue to send signals to compensate for motion for some time, even though it is no longer there. The result is the illusion of rotation in the opposite direction.